type of a smell that goes along with that because the biology of the gut has been dramatically changed. This is one of only 2 long-term studies that have ever been conducted on the genetically engineered safety. USDA pulled together 26 scientists from all over the United States, agronomists, toxicologists, veterinarians. They had 26, and the evaluation team called it a technical advisory committee to determine the safety of genetically engineered crops. After 3 years, this was in 1995, that they were pulled together, funded. After 3 years, they wrote a letter to the EPA that appears it's an open letter. They asked that their names not be attached to it because they were concerned about revenge or vindictive activity against them. It's an open letter. The EPA did withhold their names, but since it had already been announced, most of their names are fairly well known. But they wrote this letter because they said, we're unable to perform the function that you set us up for because the company stated that these materials are proprietary. They're patented, and they refuse to give us access to the isogenic lines. We can't do the studies. And then they said for 2 or 3 of them that were able to obtain materials, they said, as soon as we started seeing negative data, we were prohibited from publishing and told that if we dared publish, they would sue us. So there are only 2 studies. The pig study from a long-term standpoint, and the other study is the one of Charles-Eric Serlini, the University of Caen in France, and I'll show you that in a few minutes. Animals can tell the difference, though. I mentioned the formaldehyde. With Shiva's research, that gave us at least an explanation for how animals can tell the difference between GMO and non-GMO, but it may just be remembering that you had a stomachache earlier. But if you look at these lines here, these are isogenic lines, so you have the parent that's not genetically engineered, and then the other one that the only difference between them is the genetic engineering. You can see which ones the rats preferred. And Gilbert Hostetler, who is the corn breeder in this situation, or the salesman here, said maybe those rats are trying to tell me something I ought to know. The 2 ears up in the top, again, are isogenic lines of triple stack, genetically engineered and non-engineered. You can tell the ones that the squirrels preferred. Got a little hungry during the winter time. These ears were up there 9 months. So they nibbled on the grain a little bit, on the engineered grain, but didn't really go after it. Had a farmer, came up before a presentation a few months ago in Florida, said he was there to listen to me, but that he thought that genetic engineered sweet corn was the greatest thing since sliced bread. I said, what makes it so great? He said he's grown sweet corn for 30 years or so, ships it up to the Yankees up north. Satisfies our palate. But he said this is the first time in all the time that he's grown sweet corn that the raccoons didn't take a single ear. So I turned to him and I said, so you want to feed that to your grandkids and your great-grandkids? Because there's a reason. We're not sure whether it's the formaldehyde, whether it's other proteins or other problems, but they can tell the difference. We can't. There are plenty of reasons why we should avoid it, though. In 2002, United Stock Growers testified before the Senate Ag Committee of 2 conditions that were threatening the survival of their industry. One of them was premature aging. You take a prime beef to market, It's graded down as though it's a 10 or 12-year-old cow being pulled out of a dairy. You're not getting reimbursed for that effort that you've put in it. For that pride that you have in your workmanship isn't manifest in the end product. The second condition was reproductive failure, infertility, and a high loss of pregnancies. In this country alone, USA Today last year reported a 30% decrease in fertility in humans in this country in just the last 5 years. You look at the number of fertility clinics, we have 14 now for every one that we had in 1990. And you say, what's changed? And then as one of the veterinarians that I worked with on a special project, cooperative research, went over to his medical school because he wanted to see if there were similarities of what he was seeing with the animals in this situation with high loss of pregnancies, miscarriage, and with what was happening with the human population. His medical colleagues said, we don't even keep track of them anymore. Miscarriage is so common. It's not unusual for a woman to have 4 or 5 miscarriages before she can have a live birth. I can tell you that's not normal. It's a tragedy for society. They look at that, as they indicated in that testimony, 40 to 50% loss. We had a dairy that had 70% loss, along with about 30% infertility, and the end result's bankruptcy. 2 veterinarians, 2011, surveyed all of the dairies from Mexico to Canada, all of them in North America. Some of the data that they published in Hort's Dairyman, the November 2011 issue, you can see up there that 47, 49, 48% of the herd was pregnant at one time. And then you look at the bottom line down there, the percentage that's pregnant now, about a 50% loss. You're not going to stay in a dairy business very long if you can't have some calves. And then you look at that line next to the bottom up there, the services for all cows, 4.3 for our 100 cow dairy in Meridian. When I grew up, we averaged 1.2. Father's pretty upset when he had to have a cow in for the second time. That's lost time, that's money, that's reduced production efficiency. Agriculture is a basic infrastructure of any society. The efficiency of agriculture is going to determine how many doctors you have, how many teachers you have, how much vacation time you have. If you're going to destroy your production efficiency, you're going to destroy and impact all the rest of society. And we see that hitting us very hard. Again, glyphosate's a very potent antibiotic, very broad spectrum. You can see all of these organisms on the left here are all beneficial organisms. They make nutrients available, they manufacture vitamins, they manufacture aromatic amino acids that we have to have, that we can't do on our own. Same thing with the animals. This is research that was done with poultry. See the same thing. But the pathogens are over 4,000 times more tolerant to glyphosate than the beneficial organisms. And so you see your Salmonella and your Clostridium, and your E. coli, your Listeria, your other pathogens that are all free to move then because your beneficial organisms that would normally suppress them have been eliminated with the glyphosate in our feed. Takes 1/10 of a part per million to be toxic to all of these organisms on the left. It takes over 4,000 times that to start to touch your pathogens. So that we see then not just the diseases in our animal production, but also in our human population. So Dr. Monica Kruger at Leipzig University worked for a number of years to understand Clostridium botulinum and the chronic botulism that it produces. Clostridium's a ubiquitous organism. It's in dust and dirt, on our foods and everything else. But if we have a healthy gut microbiome, that organism doesn't do anything. What Dr. Kruger showed was that if you have a healthy microbiome, you can see your beneficial organisms over there in the blue are the predominant organisms in the GI tract. Your Clostridium never has a chance to develop, that little yellow bar, so it's not producing the bot neurotoxins. But you get over here with 1/10 of a part per million glyphosate in the feed, and you eliminate your beneficial organisms that are protecting you. They're providing your immune system. They're providing your suppression of the organisms and vitamins and minerals so that the Clostridium then develops, produces the bot neurotoxin, and it's just a matter of time, as you see on the top, before the cow dies. In man, we call this chronic fatigue syndrome. We usually don't have the lethality with it. You just wish you were dead because you don't have any energy to do anything. You don't have the ability and the function that you need to have an enjoyable quality of life. With infants, we call this disease sudden infant death syndrome. An infant doesn't develop that gut microbiome until 6 months to a year. If you're going to be feeding your infant solid foods, the American Academy of Pediatricians has recommended that you breastfeed for at least 6 months because that's the source of the probiotics in order to develop that gut microbiome that will protect them and avoid that bot neurotoxin or the production of that bot neurotoxin in the GI tract. We see the same thing to other entities in the environment. We've lost 50% of our pollinators in this country from colony collapse disorder. Bees have to have microorganisms in their honey crop, in their stomach, in order to digest the honey and the bee bread, the protein. What we see with colony collapse disorder is 3 conditions. The bees are deficient in micronutrients. The plants that they're foraging on are deficient in micronutrients, so they're not getting them. That's why we're also short on micronutrients. The bees also have plenty of honey and bee bread in the hive, but they're not able to digest it because lactobacillus and bifidobacterium that are their microbiome are sensitive to the glyphosate that they're picking up on the pollen because it accumulates in those reproductive structures. They bring it back to the hive, and then they succumb because they're starving, because they can't digest the honey and the bee bread without the lactobacillus and bifidobacteria. When they do go out to forage, they never learn how to do it efficiently. They can't find their way back because glyphosate's also a very powerful endocrine hormone disruptor. And then you tie glyphosate with another endocrine hormone disruptor like the neonicotinoid insecticides that are also systemic chemicals. And you have a recipe for disaster. And you can see that in the system and the study of Amos here, where he had his bees foraging on non-GMO versus the GMO. You see the honey crop and the normal honey crop, everything is very liquid. It's being digested. It's being utilized by the bee. When they're foraging on the GMO, they have the glyphosate that kills the lactobacillus and bifidobacteria, so that they can't digest it, and it becomes just a bunch of gravel that's in the honey crop, and they're starving to death, as well as having the endocrine hormone disruption, and in that starvation you see the tissues will eventually die.